At 9:32 on the morning of October 10th, 1958, Chief Engineer Nathan Eldon Tanner stood on the prairie 14 kilometers east of Burstall, Saskatchewan, watching the first section of 36-inch steel pipe being lowered into a trench that would eventually extend 3,700 kilometers across Canada. 59 years old, 31 years in energy development. He was supervising the construction of the longest natural gas pipeline ever attempted, a project that would either unify Canada's energy market or become the most expensive engineering failure in the country's history. The welding crews had numbers that made conventional pipeline engineers nervous. 48-inch diameter pipe in some sections, operating pressure of 1,000 pounds per square inch, transmission capacity of 8 billion cubic feet per day at peak flow, a route that crossed the Canadian Shield, the prairies, muskeg swamps, and 600 rivers requiring specialized crossings. Parliament had approved TransCanada Pipelines Limited in 1954 after years of political debate about whether Canadian natural gas should be exported to the United States or reserved for Canadian consumption. Alberta had vast gas reserves discovered during oil exploration, reserves large enough to supply central and eastern Canada for decades. But the gas was in Alberta. The population was in Ontario and Quebec. The distance between them was 3,000 kilometers of wilderness, farmland, and bedrock. Tanner had spent 3 years planning the route, negotiating with landowners, and ordering materials. His construction crews would lay pipe through terrain that ranged from prairie grassland to Precambrian bedrock to Quebec's Laurentian forests. They would work through prairie winters where temperatures dropped to -40 and summer conditions where heat made steel too hot to touch. The first pipe section settled into the trench. Welders began joining sections with precision welds that would contain natural gas at pressures that could rupture steel if the work wasn't perfect. The pipeline had begun. The problem started in 1947 when Imperial Oil discovered the Leduc oil field near Edmonton, proving that Alberta contained enormous petroleum resources. Subsequent exploration found even larger natural gas deposits, gas that oil companies considered a nuisance byproduct that had to be flared or re-injected because no market existed for the volumes being discovered. Alberta's gas reserves were estimated at 9 trillion cubic feet by 1950, enough to heat every home in Canada for 30 years. But Alberta's population was 800,000. Ontario's was 4.6 million. Quebec's was 4 million. The gas was in the wrong province. Conventional thinking said pipelines longer than 1,000 kilometers were uneconomical. Friction losses and compression costs made long-distance gas transmission too expensive. American companies proposed building pipelines south from Alberta to export Canadian gas to U.S. on markets, a solution that would generate revenue for Alberta, but leave central and eastern Canada dependent on American gas imports or expensive coal and oil. C.D. Howe, Canada's Minister of Trade and Commerce, rejected export-focused proposals. He wanted a Canadian pipeline serving Canadian markets. In 1951, he challenged industry to design a transcontinental system that could deliver Alberta gas to Ontario at competitive prices. Engineers said it couldn't be done. Politicians said it would bankrupt any company that tried. C.D. Howe said it would happen anyway. TransCanada Pipelines Limited was incorporated in 1951 with a mandate to build the impossible pipeline. The company raised capital, hired engineers, and began route surveys across terrain that nobody had mapped for pipeline construction. Nathan Eldon Tanner joined as chief engineer in 1955. He had built pipelines across Alberta and understood compression technology, steel specifications, and the mathematics of pressure drop over long distances. He also understood that TransCanada's success required innovations that hadn't been proven at continental scale. The key innovation was compression. Natural gas loses pressure as it flows through pipe due to friction. A 3,000-kilometer pipeline required compressor stations every 100 to 150 kilometers, facilities with turbine-driven compressors that boosted gas pressure back to transmission levels. Tanner designed 27 compressor stations, each housing multiple 5,000-horsepower turbines. Construction began in Saskatchewan in 1958, because the Saskatchewan section connected Alberta's gas fields to Winnipeg's market. A 1,400-kilometer segment that would prove the system's viability before extending east. If you want to see how Nathan Tanner engineered the longest natural gas pipeline in North America across terrain that had defeated previous attempts, please hit that like button. It helps us share more forgotten stories like this. And please subscribe if you haven't already. Back to TransCanada. The construction proceeded in sections. Saskatchewan to Winnipeg completed in 1958. Winnipeg to the Ontario border completed in 1959. Northern Ontario, crossing the Canadian Shield, completed in 1960 after crews blasted through bedrock and laid pipe across terrain where winter lasted 8 months. Chief Construction Supervisor William Morrison, 52 years old, veteran of multiple pipeline projects, managed the workforce that peaked at 8,000 workers spread across 2,000 kilometers. Morrison divided the route into 80-kilometer sections, with crews working simultaneously on multiple sections. Welders joined pipe sections with precision welds inspected by X-ray. Coating crews wrapped completed welds with protective layers. Trenching machines excavated ditches 2 meters deep. Side boom tractors lowered pipe into trenches. The pace was relentless. Crews completed 4 to 6 kilometers per day on prairie sections. Progress slowed to 1 to 2 kilometers per day in the Shield, where bedrock required blasting. River crossings required specialized techniques. Boring under riverbeds or directional drilling to place pipe beneath water obstacles without disturbing navigation. 3 workers died during construction. 1 was killed when a side boom tractor overturned while lowering pipe. 2 died in a natural gas explosion during hydrostatic testing when a weld failed under pressure. The names: Robert Chen, 34, Michael Dubois, 41, Thomas McLeod, 38. The pipeline continued. Compressor stations presented unique challenges. Each station required turbines, heat exchangers, control systems, and gas storage to maintain steady flow despite demand variations. Chief Compressor Engineer Harold Westbrook, 48 years old, a specialist in turbo machinery, designed stations that could automatically adjust compression based on downstream pressure readings transmitted by early telemetry systems. The Kapuskasing compressor station in northern Ontario became the model. The facility housed 4 solar Saturn turbines, each generating 5,000 horsepower to drive centrifugal compressors that boosted gas pressure from 600 psi back to 1,000 psi. Cooling systems dissipated waste heat from compression. Control rooms monitored temperatures, pressures, and flow rates continuously. The mainline reached Toronto in November 1960. Gas began flowing from Alberta to Ontario's largest market. 2,800 kilometers through pipeline that operated at pressures and flows never before attempted in Canada. The extension to Montreal and Quebec City completed in 1962, adding 800 kilometers and creating a truly transcontinental system. The total length, 4,500 kilometers from the Alberta border to the Quebec-Vermont boundary, made TransCanada the longest natural gas pipeline in North America. The immediate impact was measurable. Ontario's natural gas consumption increased 400% between 1958 and 1965 as utilities converted from manufactured gas and heating oil. Home heating costs dropped 30% compared to oil furnaces. Industrial facilities switched to natural gas for process heat, reducing costs and improving efficiency. Quebec followed the same trajectory. Montreal's utility, Gaz Métropolitain, connected to TransCanada in 1962 and began systematic conversion of the city's heating infrastructure. By 1970, 600,000 Quebec households heated with Alberta natural gas delivered through TransCanada's pipeline. But continental integration created continental vulnerability. The system operated with minimal storage capacity and limited redundancy. Gas flowed continuously from Alberta to meet real-time demand in central and eastern Canada. Compressor stations maintained pressure. Control systems balanced supply and demand. The entire system depended on uninterrupted flow. Today, the TransCanada Mainline, now operated by TC Energy, extends over 14,000 kilometers, including lateral lines and extensions. The system transports approximately 8 billion cubic feet per day at peak capacity, serving utilities, power generators, and industrial facilities across 5 provinces and multiple U.S. states. The pipeline provides heating fuel for millions of Canadian households through connections to local distribution companies. Enbridge Gas in Ontario serves 3.8 million customers. Energear in Quebec serves 520,000 customers. All depend on TransCanada delivering natural gas continuously. And the entire system depends on compressor stations, control systems, and pipeline integrity functioning normally. An extended system failure, whether from severe earthquake rupturing pipe in vulnerable sections, cyber attacks disrupting control systems, or cascading equipment failures at multiple compressor stations, would create immediate heating emergencies across central and eastern Canada during winter months. Residential heating would fail within hours as local distribution pressure dropped below operational minimums. Industrial facilities using natural gas for process heat would shut down. Natural gas power plants generating electricity would go offline, creating secondary electrical supply crises. The economic impact during winter would exceed $2 billion per day. But the human impact would be worse. Millions of households would lose heating during Canadian winter when temperatures routinely drop below -20. Emergency shelters would be overwhelmed. Hospitals would operate at reduced capacity. Vulnerable populations, elderly, homeless, low-income families, would face life-threatening exposure. The 2021 pipeline explosion at a compressor station in British Columbia demonstrated this vulnerability on a regional scale. The explosion shut down a major transmission line, creating natural gas shortages in BC that lasted 3 weeks during winter. Households reduced usage. Industries curtailed operations. The province narrowly avoided widespread heating failures. Unlike electrical grids with distributed generation and alternate supply paths, natural gas systems have limited redundancy. TransCanada's Mainline is a single corridor with no parallel infrastructure. Storage capacity exists, but provides only days of supply during peak winter demand. Alberta gas flows east continuously, or the system fails. Nathan Eldon Tanner served as TransCanada president until 1961, overseeing completion of the transcontinental system. He retired from pipeline operations to pursue other interests and died in 1982 at age 83. The compression technology and route planning he established remain the foundation of TC Energy's operations. William Morrison continued managing pipeline construction across Canada until his retirement in 1975. He died in 1996, age 89. The construction standards he enforced, particularly weld inspection and pressure testing, prevented countless potential failures. Harold Westbrook designed compressor stations until 1978, establishing redundancy protocols and automated control systems. He died in 2003 at age 91. The TransCanada Mainline operates continuously. Control centers in Calgary and Toronto monitor flow, pressure, and compressor performance across 14,000 kilometers. Turbines run 24 hours per day, maintaining the pressure that pushes 8 billion cubic feet of natural gas east from Alberta. Gas flows through pipe buried 2 meters underground, invisible to the millions who depend on it, arriving reliably every second of every day. And somewhere in Saskatchewan, that first section of pipe that Nathan Tanner watched being lowered into a trench on October 10, 1958, is still carrying natural gas east. Still functioning after 66 years, still essential to Canadian households that couldn't exist without it. The system continues. Canada depends on it continuing. If this story moved you the way it moved us, do me a favor, hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about infrastructure that unifies nations. Real people, real engineering, real human stakes. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You're not just a viewer. You're part of keeping these memories alive. Tell us your location. Tell us if you've worked in energy, pipelines, or utilities. Just let us know you're here. Thank you for watching. And thank you for making sure Nathan Tanner, William Morrison, and the 3 workers who died building this system don't disappear into silence.